Okay, we are going to pick up where we left off yesterday. This is our first example. Y equals -3 sine of 2 pi x. The first thing I want you to recognize is, where do we start when we want to graph? The first step is finding the period length. So the first step, and sometimes they just refer to it as the period, it's the length of one cycle. To do that, we always take 2 pi for this function, for sine and cosine. We always take 2 pi and we divide by whatever is stuck with the x. So whatever is in front of the x and stuck to it. In this case, it happens to be 2 pi. When I take 2 pi and divide it by 2 pi, a lot of you use this mathematical term wrong, but you say they cancel out. Really, they reduce down to 1. So we know that one cycle, or 4 steps, the length of it horizontally is a distance of 1. On your desk, please do the same thing that I'm doing. Make a fairly long horizontal line. We are going to do 2 cycles to the right, so 8 steps. 1, 2, 3, 4, 5, 6, 7, 8, and 1 cycle to the left. The length of the period says after 4 steps, the horizontal distance will be whatever this value is. So here's step 1, 2, 3, and 4. Underneath this, I can write 1. When I finish 1 cycle, it will be a distance horizontally of 1. Step number 2, we need to identify what the x scale is. What is the x scale? It's the distance horizontally from one step to the next. These are all equal distances. To figure out the x scale, we're always going to take the period length and always divide it by 4. Why is that? Because each cycle has 4 steps. Now, I'm going to take whatever this answer is. It happens to be 1/4. It does not have a pi. And you're wondering, like, yesterday they had pi's. What happened? Notice the pi's, again, you want to say were eliminated. Really, they're simplified, right? They no longer exist after we simplify. So in step number 1, please write down 1/4. If you were in class yesterday, I showed how we can use our calculator as a tool to figure out steps 2 through 8 as I graph 2 cycles. So this is the quick way. I'm on step 2. I'm going to take it times whatever the x scale is. If I get a decimal answer, I'm going to turn it back into a fraction. 1/2. Step 3, turn it back into a fraction. You can see step 4 just reduces to 1. Step 5, we turn it back into a fraction. Step 6, we turn it back into a fraction. And I'm just going to finish it out here. Step 7 and step 8. Now, after I do 8 steps to the right, I'm going to do 4 steps to the left. I get to take these 4 steps, and I'm literally just going to reflect them across the y-axis and include the negative. So -1/4, -1/2, -3/4, and -1. So we are on right now to step 4. We found the period length, step 1. We found the x scale, step 2. I've identified these values using the x scale, step 3. Now step 4 is the output and input chart. Where do I choose what values go into the input? You are going to put down the steps 0 through 4. So step 0 is 0. Step 1 is 1/4. Step 2 is 1/2. Then it's 3/4. And step 4 is 1. Step 0, 1, 2, 3, and 4. Once I know steps 0 through 4, we're going to use our copying skills to do the second cycle to the right and a cycle to the left. Let's get started based on what we did yesterday. Let me grab a piece of paper right now. So what I'm going to do is I'm going to write down this original function. This original function said y equals negative. I'd like you to do the same. -3 sine of 2 pi, and then I'm not going to put an x here. I'd like you to put a parenthesis. It's going to be nicer for you because you get to just erase what goes in the parentheses. I'm going to have to rewrite this 5 times. That's okay, but your job will be nicer on the desk. So I'm going to start with my first one here. So my first input value is 0. Remember to please have that unit circle available. So what I'm going to do is I'm going to take 2 pi times 0. Well, I know 2 pi times 0 is 0. What's my next step? My next step is to go on the unit circle and locate where 0 is and tell me what is the sine value. So that's what I'm going to do right now. Let's find 0. Here is 0. Well, how do I know which number is the sine? CBS, cosine before sine. That means sine is the second number. So the sine of 0 happens to also be 0. When I evaluate this portion, I get 0. Now I take it times -3. -3 times 0 is 0. So the output value is 0. How does that help this? Notice it says y equals. Y is going to tell us this distance above or below the x-axis. And sometimes we're even going to be on the x-axis. So at 0, I'm going to be at 0. So I'm going to make a dot right here. Now I'm going to do the same thing. I'm going to fold this under so I have a little more space. I would like you to be lazy and just erase what was inside the parentheses. So y equals -3 sine of 2 pi, and now I go on to the next step, times 1/4. So I'm going to make my life easier. Now those that have stronger math skills, you're just going to simplify in your head, and there's nothing wrong with that. That's what I would do. But I want to demonstrate how to simplify this on the calculator. Forget about there being a pi symbol. We're going to take 2 times 1/4. If I get a decimal, I'm going to turn it back into a fraction. Okay, so I get 1/2. So let me rewrite this. This is y equals -3 sine of 1/2, and now I attach the pi. So all I did is I took 2 times 1/4 on a calculator and simplified it. If you could do that in your head, wonderful. That really helps. What's next? I want you guys to locate on the unit circle where is 1/2 pi. That's the same as pi over 2. 1/2 pi is the same as pi over 2. That's right here. And then we want to know what is the sine at that position. The sine at this position is 1. So now I want to take 1 times -3. What is 1 times -3? It is -3. All right, so I'm going to keep going here. Let's do 1/2 now. So I have y equals -3 sine of 2 pi. And now I'm going to plug in my next output, which is 1/2. Again, I know I can simplify 2 times 1/2 in my head, but if you're not as comfortable, you're going to take 2 times 1/2. If we get a decimal answer, you'll turn it back into a fraction. This time we did not. So y equals -3 sine of 1 pi. What does that mean? That means I need to find 1 pi on the unit circle, and then I need to evaluate the sine. The sine at 1 pi is 0. So this becomes 0 times -3, and 0 times -3 is 0. I'm going to do 2 more. I'm going to speed them up now. Here we go. Y equals -3 sine of 2 pi times 3/4. I know that if I use a calculator, I get 6 over 4, which reduces to 3 over 2. So I want to go on the unit circle and find where is 3 pi over 2. That's right down here. The sine at that value is -1. So this is -1 times -3. -1 times -3 is +3. I've got 1 left to do. Y equals -3 sine of 2 pi times 1. Well, 2 pi times 1 is simply 2 pi. That's easy. So I'm going to find 2 pi right now. 2 pi is located right here. And I know the sine is 0. 0 times -3 is simply 0. Those output values tell me at each one of these input locations where to go, above or below or on the x-axis. So I'm going to go to 1/4, and I'm going to go down 3. 1, 2, 3. I'm going to go to 1/2, and I'm going to stay on the x-axis. I'm going to go to 3/4, and I'm going to go up 3. And I'm going to go to 1, and I'm going to be on the x-axis. So I'm going to connect these, making sure that I have a curve. Now, how do I use that in order to create the next pattern? I think of this as a valley and then a hill. I want to continue that pattern. So valley and hill. Making sure I go down 3 and up 3. And then it needs to go the opposite direction. So it continues to be this continuous curve. Now, why do we graph it? We graph it so that we can understand the function. So, for instance, if I called on somebody, listen closely, and I said to you, please evaluate this function at 3/4, you would go to 3/4, and you'd go up or down until you hit the function, and then you'd look across. The answer is 3. Please evaluate this function at 5/4. I find 5/4, I go up or down until I hit the function, and the answer is -3. One last one. Please evaluate this function at -1. At -1, it's actually on the x-axis, which has a y value of 0. Here's our second example for today. Our second example. What's the very first step? Turn to your partner. You have 3 seconds. Go. What do you do first? You find the period length. So I'm going to take 2 pi, and I'm going to divide by whatever is stuck in front of the x. In this case, it's just a 3. This is going to be my period length. That means after 4 steps, I'm at 2 pi over 3. Here we go. Step 1, 2, 3, and 4. I'm writing down 2 pi over 3. Now, I'm thankful for the use of a calculator because this is not going to stress me out. How do I find the x scale? The x scale says take whatever your period length is and divide it by 4. So please grab your calculator. In parentheses, take 2 divided by 3 because it's a fraction. Forget about the pi. And then divide it by 4. Now, if we get a decimal, let's turn it back into a fraction. So my x scale is not just 1 over 6, it's 1 pi over 6. So let's come over here. This is 1 pi over 6. Turn to your partner. Let's pretend your partner was not here yesterday. How can you use a calculator to only find step 2 and step 3? Ready, get set, go. Talk to your partner. How do we use a calculator? I'm going to put in a 2 for step 2, and then I'm going to take it times the x scale, but I'm going to omit or not use the pi when I plug it in. I turn it back into a fraction, and I have 1 pi over 3. This is step 3. I'm going to take it times the x scale. Again, omitting the pi. Turning it back into a fraction, 1 pi over 2. And we should get, in our 4th step, the exact same thing. Turning it back into a fraction, we can see we have 2 pi over 3. I'm going to keep going. So, step 5. Whoop. Step 5, turning it back into a fraction, is 5 pi over 6. Step 6, we're going to see, just get an answer of 1, is 1 pi. Then we're going to have 7 pi over 6. And then we're going to have 8. We're going to have 8 times the x scale, which is 4 pi over 3. Okay, if you have not done so, please copy mine. So these are the first 8 steps, and then I'm going to copy to the left. All right, you also may recognize that looks very similar. Look at this. I'm starting at 1 pi over 6, and I told you these are all going to be running with equal distance apart. So that's step 1, step 2, step 3, step 4, step 5, step 6, 7, and 8. So I'm so sorry, I should have zoomed out here. But we're taking equal increments of 30 degrees or pi over 6. All right, our 3rd step was to write this down. Step number 4, turn to your partner. What is step number 4? Go. Make it input-output, please. Now, a lot of students, because we're only on our 2nd practice problem of the day, are going to forget what do you write down. It is not steps 1 through 4, it's step 0 through 4. So step 0 is 0. Then it's 1 pi over 6, 1 pi over 3, 1 pi over 2, and 2 pi over 3. Now, I'm going to teach you how to cheat right now. Is everybody ready? Here's how to cheat. When we graph these, let me bring back a picture. Do you guys see how this one was valley and then, does everybody look at this? Does everybody see how this was valley and then hill? Yes? Okay. What was our first example? Was it hill and then valley? What was another one? Let's see about this one. Let's look at this example. Does everybody see how this is hill and then valley? You see that? Okay, so I'm going to teach you that after you do 2 inputs, you can cheat. So pay close attention. You don't have to. You can do all the work, but I'm going to show you what we can do. Let's start by plugging this in. I'm going to come back up to this function. I'm going to write it down. You should do the same on your paper. And then you're going to put a parenthesis where the x was. In that position, I have an input value of 0 for the very first input. 3 times 0 is 0. So I want to know, what is the sign of 0? So I'm going to grab my unit circle. I'm going to locate 0, and I can see the sign is 0. So over here, I put a 0. All right, let's try the next one. Now I'm going to be lazy here. I'm going to change this to 1 pi over 6. You're going to take 3 times 1 pi over 6. And if you're not great with doing that in your head, you're just going to take 3 times 1/6. Omit the pi. They'll come back into play in a second. If you get a decimal, you turn it back into a fraction. So I want to know 1 pi over 2. This is equivalent to 1 pi over 2, which is the same as pi over 2. So please find on your unit circle, please find where pi over 2 is. Pi over 2 is right here, and the sign is 1. The sign is 1. So over here, I'm going to put a 1. All right, that means I'm going to go to an input value of 1 pi over 6, and my output value, or the distance above or below the x-axis, is 1. Please turn to your partner. If you were going to make a prediction, do you predict that this graph is going to be, look up here, do you predict that it's going to be valley and then hill for a cycle, or is it going to be hill and then valley? And whatever your prediction is, how do you know that? Turn to your partner. What do you think? I didn't say anything. Eileen, what do you believe? Okay, Eileen says hill valley. Angel, do you agree or disagree with her? And what is your reasoning? Okay, you guys are right. What is your reasoning? There's a 1. True. Who can give it even simpler? Which direction did we go in step 1? We went up. Okay, so guess what? We know the pattern because it's a wave curve. It does the same thing over and over and over again. So guess what the next step is going to be? Right back here. So I made my hill, and now I'm going to do a valley. Make sure it lines up. And there's my first cycle. I want you to take that cycle and copy it to the right, and also continue to keep the wave curve going 1 cycle to the left. Make sure they line up, because you are going to have a practice quiz on your ability to read this wave curve in about 1 minute. What do you mean, Miss Bradley? What do you mean you're going to have to evaluate this? So here's what I'm going to ask. Aubrey just raised her hand. Thanks, Aubrey. Aubrey, if you were going to evaluate this function without a calculator, but using a graph, at the input value of 1 pi over 6, what would be the output?
1 pi over 6.
Okay, but look at my graph. So find 1 pi over 6, and then you're going to go up or down until you hit it. And once you hit it, look off to the left and align it up with the y-axis. 1. Ari, evaluate this function at 1 pi over 2. Let's see. -1 is right. Okay, you ready? Miguel, evaluate at 2 pi over 3.
It's on the 0.
0, right, it's on the x-axis. Leslie, evaluate at -2 pi over 3. Which is a value of what for y? 0. In class right now, students are working, if you're watching this video, and identifying what is the period length, also just known as the period, and then using that information to identify the x scale. They are not graphing, they are simply coming up with those two, identifying those two facts. So I'm going to take 2 pi and always take whatever is directly in front of the x. In this case, it's a 4. So saying that the period is 2 pi over 4 is not wrong. But if you see an answer sheet, it's not going to say 2 pi over 4. It's going to be reduced to 1 pi over 2. And you're like, well, how do I do that if I can't do that in my head with ease? Again, you omit the pi, take 2 over 4, hit math fraction, enter, enter, and you can see we get the 1/2, and then attach the pi. Okay, this is my period. What does that mean? It means after 4 steps, 1, 2, 3, 4, I'm at 1 pi over 2. You're not graphing, you're just watching. Next, how do I use that information to find the x scale? Well, the x scales, we're always going to take this and divide it by 4 because there's 4 steps to each cycle. Well, how can I do that on my calculator? Take 1 over 2, omit the pi symbol, and divide it by 4. If I get a decimal, turn it back into a fraction. I got a decimal, turn it back into a fraction. I end up with 1 pi over 8. Turn to your partner while I write that down to make sure you both understand. Go.
I was a bit confused with the first negative, but I just forgot to take out the pi symbol.
Then I'm going to use the calculator to determine the next one. So I have the next ones. Here we go. I have the second step, and I'm taking it times 1/8. If I get a decimal, I'm going to turn it back into a fraction. I have the third step times 1/8, which is the x scale. I'm turning it back in. Well, I finished this because I've asked you not to graph. Can you turn to your partner and ask, do they understand how to come up with those numbers on the bottom? I consistently saw in homework in first period they did not. So talk to your partner, please.
Okay, I just see myself.
Okay, you ready? And now we're going to use the trick. Here's the trick. But knowing that a lot of you will be entering into advanced placement calculus next year, you have to show all of your steps on the test. So you can know what the trick is, but you have to show your steps. So turn to your partner in 5 seconds. All I want to know is turn to your partner. What values would I put here based on what I put on my x scale? Go. What values would I put here? So steps 0, 1, 2, 3, and 4. I'm only going to do the first 2. Let's get started. You ready? You are not graphing. You're just helping me with step 1 and step 2. I'm going to write the function. Y equals -4 sine of 4. And I'm not going to put an x, and I'm going to put in now the input value of 0. 4 times 0 is 0. And so I'm going to look on my unit circle and identify 0, and then look, what is the sign? Here's 0, the sign is 0. This portion equals 0, and I know -4 times 0 is 0. Okay, I'm going to go on to the next input value. So y equals -4 times the sine of 4. I'm not going to put in the x. I'm going to put in 1 pi over 8. Now, if I take 4 times 1 pi over 8, and you're not comfortable doing it in your head, omit the pi symbol. If you get a decimal, turn it back into a fraction. So I'm looking right now, where is 1 pi over 2? And then I'm going to identify the sign at that location. 1 pi over 2 is the same as pi over 2, and the sign is 1. So this equals 1, and 1 times -4 is -4. And you may be wondering, why am I stopping? I'm stopping here because I recognize patterns of sine functions. So is this a hill and then a valley, or a valley and then a hill? Valley and a hill because I went down first. So here's going to be a valley, and then we're going to get a hill. And you're just watching here, and then you're going to evaluate, what does this look like? What does this mean? Should be a little more rounded. Elijah, please evaluate for me. For this particular function, at 1 pi over 4, what is the output?
0.
0. Please help me out, Nathan. At 5 pi over 8, what is the output? Okay, why is this difficult? On your desk, if you're here with me live, please put a 1 in front of the x. That's the difficult part here. When I identify the period or period length, I'm taking 2 pi and I'm dividing by whatever is stuck with the x. So I'm dividing it by 1 divided by 4. And if you're not comfortable with that, we're going to omit the pi symbol. And when I divide here, I'm going to use parentheses. I'm going to use parentheses for the fraction. And we're going to see we get an answer of 8. The period is not 8. What do I still need to bring back in? The pi. So this has a period length of 8 pi. This has a period length of 8 pi. Let's look at the x scale. The x scale would be 8 pi divided by 4, which is 2 pi. This is going to be very easy to do. I wish I could draw a little bit straighter lines, but we're just going to go with it. 1, 2, 3, 4, 1, 2, 3, 4. Okay, 2 cycles to the right, 1 cycle to the left. Okay, you ready? Turn to your partner. 1, 2, 3, 4. What value should go underneath the 4th line?
Pi.
8 pi. Why is it 8 pi? Turn to your partner. Why is this 8 pi? Period length means when one cycle is done and you've completed 4 steps, what is the length along the x-axis? Now the x scale is 2 pi. Now this is easy because we can count by 2 pi's. 2 pi plus 2 pi is 4 pi. 4 pi plus 2 pi is 8. So this is easy. We're just counting by 2's. Okay, and then I'm going to make my little table because I know that's in the future something that I'm going to have to fill out. And I'm going to show you that if this was a test, I'm going to show you exactly how I'd get around being lazy but still putting in answers. So there's my input and my output. I have 0, 2 pi, 4 pi, 6 pi, and 8 pi. If your question is like, how far do you have to go? You're going to go steps 0 through 4. Step 0, 1, 2, 3, and 4. Okay, we're going to get started here. I'm going to start with 0. 1/4 times 0 is 0. So I want to go find 0 in the unit circle and I want to identify what is the sign. So let's find that. Here's 0 and the sign is 0. This portion is 0. What's 0 times negative 1/2? 0. Okay, next up, I'm going to do 2 pi. And I'm going to write this one out. This is my last one that I'm going to show work on. I have a 1/4 there, and now I want to take it times 2 pi. If you're not comfortable taking 1/4 times 2 pi, you're going to grab your calculator. Okay, 1/4, and I'm going to omit the pi symbol. If I get a fraction, I'm going to turn it back into, if I get a decimal, I'm going to turn it back into a fraction. So can everybody please go and find 1 pi over 2, also known as just pi over 2. What is the sign at pi over 2? It's 1. So this portion equals 1. But now I need to take it times a value up front. Negative 1/2 times 1 is negative 1/2. So how would I go about completing the graph accurately, but also filling in the table without doing much work? So I'm going to start by identifying this as 0.5, and this is going to be negative 0.5. Okay. My first step is down. That tells me this is going to be a valley and then a hill. And so I'm going to first accurately complete 2 cycles to the right. I'm in a valley and a hill. And then going the opposite direction. What I do not want to see that I saw in homework earlier today, please watch this, is this. That's not a good curve. I want to see where are your dots so I know that you're trying to connect them. Now, how am I going to fill in this chart if this is required? Okay, I'm going to go to 4 pi is 0, 6 pi is positive 1/2, and 8 pi is 0. I've filled it in, and I have my chart. One last thing, in back, David, please evaluate for me for this particular function. Looking at my graph, what is 8 pi? The output is what? 0. Thank you. Joseph, what is the output at 14 pi? 0.5. Good job. Jonathan Lopez, what is the output at negative 4 pi?
It's 0.
0.